Hey guys, welcome back to the shop. We have got 6 stainless steel impellers in here that we need to work on. They need a slight modification done to them, and I'll go over that in just a minute here and show you what we got to do. Before I get started, I want to give a mention that I know that some people have been reaching out and leaving comments about the current audio levels in some of the more recent videos, which is because what you're hearing there is the sounds from our Milltronics, the CNC mills. When we're running at some of those higher RPMs, you know, you have a certain frequency that's coming through the audio, and I know that's displeasing to some, and I apologize for the sounds. I'm working on the gain levels on the receiver for our mic system here, and I'm going to continue to play with that through the videos and see if I can find a little bit more of a sweet spot that might reduce some of those higher pitch sounds that's coming through. I know I had it set a little bit higher in some of the recent videos, and I'm making an adjustment to bring that down a little bit and see if that'll help. So you will be hearing some of those sounds in this video because I'm currently working on our purple drill indexes. I'm getting the engraving done, and part of running this shop is being able to have our CNC machines over there running and making and machining parts, and also be able to come over here and work on other projects, especially on these manual machines here, and be able to capture some video, some content there to share on the YouTube channel for you as well. So I'm aware of the sound level. I know that some people don't like it, and I apologize for it, but I'm going to do the best I can to adjust the audio level. But bottom line is that when I'm running CNC machines and I got to do this work and film video, it's just going to be a part of the videos, and it's just sort of the sounds from this shop here. But thank you to everyone that's been leaving some really nice comments from the footage lately. We really appreciate that, and I'm going to continue to share this stuff because I know you guys enjoy it. All right, so let's jump back on this project here. Again, 6 stainless steel impellers that we need to work on. This is what they look like right here. And they told me that they installed one of these guys and realized that it was running a little bit too tight, tighter than what they like it to run. It was going to cause some issues, so they took a step back, they pulled the impeller, and they went ahead and measured the seal rings on all 6 of these guys, and they've got their measurements written down right here, which this particular one I got in my hand is 4.505. And I believe all of these, there's a 504, there's a 506, and the rest of them are 504. So you're looking at anywhere from 4 to 6 thousandths over your nominal 4.5 inch size. They want these seal rings turned down to 4.498 to 499. So we've got about a thousandths tolerance right there. So that's what we're going to do. These are tapered bore impellers, and they actually come with these bushings as well. These are some split tapered bushings that come in them. All right, and then this has a straight bore through there. And they actually provided this mandrel and this tool because this is stuff that they've worked on in the past. They did provide this mandrel right here, and I went ahead and chucked it up and did some indicating over here in the lathe. It had, just because there was a lot of chuck marks on this end previously, this is the first time I've used this, there's a lot of chuck marks here. It was trying to run it out. It was trying to throw it out on the center end just a little bit. So I cleaned it up and I turned this straight, and once I set it up with the center and did some indicating, I kept having about a 1,000th or less TIR all the way through this part right here, this mandrel. So I think we've got this running nice and straight, and it's going to do the job. So we'll chuck this in, have a live center in that end, and we'll have our impeller mounted on this shaft right here to do the turning, okay? This is a tool that they made that you can use to, whenever you put these guys on the shaft, I'm going to show you this. You can use this tool, slide it down over the shaft, over the mandrel, and you can tap that tapered bushing and lock it to the shaft. And then whenever you take it out of the lathe, you can simply slip it down the other side and reach up inside the seal ring side here with the tool and tap it, and it'll tap that split bushing loose, and then you can remove it from the shaft. All right, so that's how we'll be mounting it today on the mandrel here. So I'm going to go reset the Milltronics, get another couple drill indexes going, and then we're going to jump on this and get it done. All right, we're going to use our hardtail vise with the V-jaws mounted up to help us with this job here. show you what we're talking about, how we're going to mount these up. So here's our mandrel that we're going to use. I want to put them on that direction, so we'll go ahead and put our mandrel in there. And then we have our split bushing right here. Taper on the outside, straight bowl on the inside. Now I did notice a few burrs here where the fellows that have been working with these have already used a screwdriver, but this is a really easy way to be able to get the sleeve up on the shaft there, because it is pretty tight. But I'm going to make sure that I file these burrs all along this split, just to be sure that it's not hanging it up. But what we can do is just take our screwdriver right on the very end of it and just open it up just enough, like that, where we can get it on there. You can see how tight it is. That ought to work right about there. Now I'm going to go ahead and just take our mill smooth file and just dress that again. Make sure that we don't raise a burr there. That's going to throw the impeller off. Go on this side first. I will point this out too. They've already balanced these guys once. I forgot to point that out. They've got a balancing machine. They've already balanced it. But he likes to go ahead and put a mark there where the split is of the bushing, just so when they go back together, it's kind of lined up again. So that's how I'm going to do it as well. You just push it up on that tapered sleeve there, and then you've got there, this is the little sleeve that they use to help knock it on and knock it off. And we got to go the other way. So what we can do here, we've got a V in the center of these jaws here too. We can just set it down just like so. Doesn't even really need to be that tight. Just going to hold it, slide this down, just give it a few easy taps. It's not going to take much to hold this, and there we go. So there's our impeller installed on the mandrel, and we'll go to the lathe with that. Now whenever we want to take it off, we're going to come back over here to the hardtail, and we can just do the exact same thing. In fact, we'll just do it this way so it doesn't drop down. We'll put it in these V jaws and take our tool and just bump it just like that. Simply take the impeller back off. Easy enough. So one last time, let's go ahead and put it back together. All right, we'll go over to the Precision Matthews lathe. We're going to chuck this in that I skint round. Got everything nice and true. I went ahead and double checked the 6-jaw chuck here, and I re-indicated it, and we had it less than 1/1000ths run out on repeatability. Run our live center up. That looks nice. Looks good. Just put a dial indicator on here to kind of inspect what our run out is. And that one right there is about 1/1000ths. So I think we can live with that. That's to be expected there. Let's go ahead and get our Starrett mic out. Need our 4 to 5. I want to see if I'm getting the same reading that they got. This one says 4.505. That's exactly what we're getting. 4.505. All right, so we're going to take approximately 6 thousandths off of this one here. We'll see how my standard turning insert's going to do for this stainless steel. It's a pretty good all-around insert for just about anything, so we'll just give it a try and see how that does. I'm just going to go ahead and come up here and just manually touch that shoulder. We're going to use our edge mag back indicator here. Set a 0. And I'll set a 0 up here on our DRO also. Okay, we've got the lathe set at 250 RPM running a 5,000 feed rate. So that should put us, I think, around 295 feet per minute. We'll give that a shot. Remember, we're only taking about 5 to 6 thousandths off of these things. So we're just touching them. I'm going to see if I can just kind of split it. We got it touched there. Let's see if our DRO is going to help us today. I'm touching the screen and it's not doing anything. There we go. There's 3 thousandths. My main concern here is chatter. We're taking such a small amount, hopefully that's not going to give us any issue. Everything seems to be doing pretty good so far. That one's got a little bit of a run out in it. I will get you some better video of this too, by the way. Let's just get going on one, make sure our process is going to work right, and then we'll set up our other camera and get you some little more detailed photos of the machining. Our insert looks like it's going to do a good job, leaving a good surface finish. All right, we're just going to stop it there. I don't want to get, they used a larger radius in that corner. I don't want to cut all that out of there. But you can see, put this in neutral. You can see we've got a spot there that we didn't even touch. So slight out of roundness on that. You see where we are on our measurements here. And 504 is what I'm measuring right there. So we've still got a few to go. I'm going to take 5 thousandths off of this one here. That should put us at 499 with about a 1 thou tolerance. It'd help if you put it back in gear. All right, let's give it a check, see what we landed on. All right, that time we landed on 498. So we're on the bottom end of the tolerance that they're trying to hit here, 498 to 499. And we hit 498 right there. Okay, good deal. Right there where we needed to be. And I don't even know if we need to chamfer it. It's still got a chamfer on there. So I believe I'm gonna leave that alone, and this is all we're gonna worry about, is just turning that diameter. Whenever I come up and touch that face, some of those chips are trying to stick to that surface that we just turned right there. Figured I'd go ahead and show you guys. I got some of this gray Scotch-Brite here, and I'm using that just to kind of brighten up the surface there. Getting up into that corner, there was a couple chips that were just stuck. I'm just cleaning it up. Looks beautiful. During the machining of this first impeller, I finally reached the final 2 drill indexes I'm working on over there on the CNC. So that is finished up. So you guys won't be hearing the high-pitched sound for the rest of this video. All right, we're gonna go back over to our vise to disassemble this, all right? All right, just take our sleeve, this in here. Give it a few bumps. Slide it off. Maybe I should, we'll just set this one down over here because we're going to keep the sleeves with the impellers. You can see how tight that sucker is. Just give it a little twist and it'll come right on off there. All right, there's number 1. There's number 1 completed. We'll go ahead and grab number 2 and get it done. All right, impeller number 2. First thing I need to do is knock the sleeve out of it. There's just some burrs raised up on this guy that I want to make sure is filed off there so it's not interfering with our run out. Okay, that feels pretty good. All right, going in with impeller number 2. Go ahead and give this one a little inspection as well. Let's see what it's looking like on the shaft reading here. Same as before. You got 1/1000ths or less. That's looking like about 9, maybe 9/10 or so, but right in that 1/1000ths run out. Okay, I think we're good. This one says 4.506. We'll give it a measure and see what I'm getting. I'm getting 504 on that one. I wonder if it's out of round just a little bit. I'm getting 504 on this one here, so we got 0.005 to come off of it. By the way, I told you wrong earlier. I did have 2 more of my indexes to engrave that I forgot that I set on the other side of the box. So we're working on the last 2 now. So you'll hear the mill in the background a little bit. Same thing, we've got a little run out happening on these seal rings. .503. See if we can get you a shot of that. Will it focus? It doesn't want to focus today. See that? Some days these cameras want to focus and then sometimes they don't. I don't get it. Sometimes if you turn it off and put it back to photo mode and then back to video mode, it works. Look at that. See, now it's working. 4.503. So that gives us 3 plus 1. We're going to dial in 4,000. So hopefully that'll put us there. Right at the end of the cut, it's going to do that. Right at the end of the cut. Never fails. They love to do that to you. All right, we hit just under 499 on this. Is it going to focus this time? There it goes, I think. So that'll be 498. I'm going to say 8/10. We'll see what we lined up on. That was 1/10 off, so we lined up on the 7. I'm trying to get it to focus so you guys can see this. Do you see the number 7? And then the number 7 and number 8 are lined up there. So that would be 498 and 7/10. I bumped it there. While we got it set up, let's go ahead and grab our Scotch-Brite here. Get these chips out of the way. Just helps brighten it up, makes it look nice and uniform. All right, there we go. Number 2 completed. All right, we'll take number 2 out. We'll get number 3 set up. Number 2 finished. We'll grab number 3 and keep on going. I've got something that I'm going to try on this job here. So that second impeller that we just machined, you know, I was having some of the chips try to catch between the tool and the surface there, and what that does is it scratches the surface. And oftentimes when I run that situation, I just like putting cutting oil on the surface, and it helps lubricate everything and keep from scratching. I've got a new lubricant here that I want to give a try on this particular job. So what we have, this was sent to me by Eric Peterson, and he owns a company out in Colorado Springs called TAL Lubricants, TAL Lubricants LLC. And he reached out to me. He says they have developed a 100% bio-based lubricant that is perfect for titanium and stainless steel applications. For titanium, they've got this paste that they developed here. We're not going to be using this paste today. We're going to be using the other container here, what they call their machinist snake oil. So this oil, it said this particular batch here, they're all made from vegetable oil, and this particular one is made from canola oil, and they say that they're USDA certified. Okay, maybe that'll apply in applications where you're machining a lot of parts that's going to be going into the food industry. I'm not really sure. That's what I'm guessing there, but maybe it's because of all the manufacturing that is involved with the food manufacturing all around the world. So I'm just going to take some of this snake oil here. We'll pour a little bit in another container, and I'll use an acid brush. And all I'm going to do is just brush a little bit on this surface, and I'm hoping that's going to help leave a better finish and keep those chips from trying to gall and stick to that surface. So anyway, I wanted to go ahead and give this a try. You know, they reached out earlier in the year. I think it was back in January or so. He reached out and offered to send a sample here for me to try at my convenience on some stainless and titanium applications. So that's what we're going to do. So we'll go ahead and give the old machinist snake oil a try on this impeller job. By the way, they claim that it works excellent for tapping applications. So in the future, when we got some stainless steel parts that we're going to be doing some power tapping on, we'll get this snake oil out and give it a try. Got one of my caps off of my degreaser cans. We'll just use that. Just use a little at a time. It's really not going to take very much at all. And we got an acid brush, so that's how we'll apply it. All right, we're going to go ahead and put some of our snake oil on the surface here. Let's give it our first test and see how it does. By the way, I forgot to mention that they did send the material data sheet with both of these. Let's give this one a measure and see where it lands before we cut it. .504.5. They measured it at 505, so about a half a thou difference there. .504 there, and about a few tenths difference there. All right, so just like the other, we got 5 thousandths to come off this guy here. You can see how the chips, I thought it was going to do better. The first one we did, it did fine, and now they're trying to wrap up on the tool there. And all it does is just cause problems in your finish. You see the chip trying to get behind it there. That's why I'm putting oil on it, just because it usually helps prevent the chips from galling and scratching up that surface in there. Go ahead and wipe it off, get the chips off of it, and we'll give it a measure. Almost cleaned this one up. You can still see a little low spot right in there. .503. We got 4 thousandths to come off of that. You don't want that. Stand back. Get to the end of this cut and we'll shut it off. Just hit the foot brake like that. I don't know what the deal is. That first one made a nice looking chip, and then the rest of them are going to be stringy like this. This is what you get into when you're messing with stainless steel. Well, I think the oil is definitely helping. It's got a nice surface finish on there. It did try to rub in one spot right about there, but let's see where we finished at on our sizing. All right, and we are at 598. I'm trying to get to that 10th reading right there. 598 and 8/10. So we're in between our 498 and 499. Good deal. And let's go ahead and I'm going to go ahead and polish it now. Get that oil off. And just go in there with our Scotch-Brite. All right, we're halfway home. This is number 5 we're working on. They measured it at 504. And I'm getting 504 also. 5 thousandths to come off that one as well. Chips just do not want to cooperate with me anymore. This snake oil is actually working well. Keep some lube on the surface there. It's going to help keep those chips from galling and scratching. Just wiping it to get the little fine chips off the surface there so that we can measure it and not be measuring any chips. All right, what are we getting right here? 502. Just measuring in a couple different places and see if it's machining nice and round. It's 502, so 3 thousandths. That DRO's been landing on 2 thousandths on the X dimension whenever we hit our size there, so I've just been kind of leaving it alone, knowing that if it's on 2, it should put us within that tolerance that we're looking for. The snake oil puts off an interesting smell or aroma. It definitely smells like vegetable oil. It kind of reminds me of being in the kitchen, you know, and cooking something. Get rid of these guys. All right, $4.99. Hit our target there. Check it one more time. $4.99 on the button. So that's the high side of the tolerance, but good. We'll go ahead and wipe a little of this oil off. And we got our gray Scotch-Brite here. Polish that outside a little bit. Polish the face. Chamfers have been good on all of them. There's no need to touch them up again. That looks good. I'm just going to go ahead. I want to mic it one more time just to be sure. And $4.99. Good to go. All right, number 5 finished up. We'll go ahead and get this one out and work on the last one. All right, number 6, last one up. Give it the rundown check. We've been doing that on all of them. It's been consistent. All 6 of them have been within 1/1000th of run out on that indicator there. All right, they measured that one at also 4.504. Let's see what we get. Few tenths under that, but close to it. So basically 5/1000ths to come off, just like the other ones there. Just get my Z set here. Helps if you put it in gear. Got a little run out on it. The wear ring has a little bit of run out. That's definitely going to affect the balancing. I'm sure they're going to set these up and balance them again once they get them back. They have a balancing machine over there at their pump shop. So you guys probably have noticed that I've been doing quite a few jobs for my pump customer. They had come over and visited me sometime late last year, the end of last year. I think it was November, December. They had stopped by. We used to help them with a lot of work back when I worked with my dad, and then before I was working with Dad, he did a lot of jobs over the years for this particular customer. And a lot of time had passed. I went worked somewhere else for a while. Left there. I've been working for myself for a while. And kind of fast forward through the years a little while. Need to clean that off. the pump shop, they used to have a machinist. Matter of fact, back when I used to work with Dad, Cliff, he was the machinist there at the pump shop. Cool guy. He was like my dad's age, just old school. That's what I like. That's what I remember about a lot of these older guys that I met whenever I first started working with Dad when I was in my late teens, early 20s. But Cliff, he was a great machinist and worked for them for a very long time until he retired. And then when he did retire, I know that they hired another machinist, and he worked there for a while, I believe, several years, and then he left, and I think they've hired a couple other people since that time. And currently they do not have a machinist there. So I mean, they have a shop with, they have a couple lathes, they got a couple mills, they have all the stuff that you would need to do pump machine work there, and they just don't have a machinist. So they came over here to talk to me and asked me if I'd be interested in helping them do some of this work, and I said absolutely, bring it back over here and let's help them out. All right, so I'm measuring 503 right there, so we've got 4 thousandths, 4 thousandths to take off this right here. Let's go ahead and get that set. That would be 2 thousandths up there. We'll see if we hit my target there. So anyway, as I was saying, whenever they came and visited me, I said, yeah, I'd be glad to help you get some of your work done. They're a great customer to deal with. And these types of jobs here this is good machine work. This is stuff that I enjoy doing. And it's good stuff that I can share on the channel here and make some videos and share with you guys. So hopefully they'll continue to bring us some projects and bring us some work to do. And we'll continue to share it with you guys on the channel. It has a lot to do with pump shafts and impellers, so I imagine when they bring stuff, it's going to be things like that. Some pump shafts like you guys have seen. Sometimes you got bushing work that you have to do. And every now and then you have some other things that you have to jump in and kind of help with as well. So anyway, I thought I would mention that, because we have been showing quite a few of their jobs this year on the channel. Let's see where we landed. All right, so that one, this is the first one that I'm over my target. I'm a 0.5 thousandths over. So this is 499. Do it again, 499.5. So I need to try to get about a 0.5 thou off that impeller right there. Maybe it's because I was distracted and I was trying to talk to you. Or maybe not. Maybe it's just because I landed high on our size right there. We can get a 0.5 thou off though. Should be my touch right there. See, this isn't lining up. I love my DROs, but I have noticed that all of them, every one I've ever used, can be very, very finicky when it comes to 1/1000th of an inch. That should do it right there. 2 thousandths. Well, that's where it was supposed to be to begin with whenever we were finishing our size. I will point out also, while we're just kind of talking, is that I have had a couple other companies reach out here recently about possibly doing some work for them. And one particular customer, potential customer, it's going to be CNC work. It's repetitious. They've got a few parts that they are sending me that they would like me to give quotes on batches of 100. It's actually like wear parts that go to some of their equipment. So I'm kind of looking forward to seeing what it is that they're going to send me. I saw a couple pictures of two of the parts in question, and they seemed pretty simple, like basically a piece of flat bar that's got some holes and some milling on it. And that kind of work would be pretty good for the shop here, keeping those Milltronics busy while we're over here keeping the manual machines busy as well. All right, we landed on $4.99 that time, so we took a half a thousandths off that particular pass. I'm going to check it one more time. $4.99, right on it. So perfect. Go ahead and get this one cleaned off, polished. Just getting that oil off of it. I know a lot of the folks that watch the channel absolutely love the manual machining, and I've said it many times, is that the manual machining is not going anywhere. I'm going to continue to do manual machining. It's sort of my bread and butter, and you know what I know well. Some of the lathe and the mill work anyway. But I absolutely love my modern capacity that I can do in the Milltronics, especially for repetitive work. The repeatability, that's what I always try to mention, is the repeatability. That I just love it, being able to put a piece of stock in the mill, hit cycle start, and it makes the same exact part, the same exact dimensions as the previous part, and you're not having to chase dials and you know, hash marks on the lines every time. So I'm going to continue to share with you guys whatever comes through the shop, whether it be CNC work, manual work, or a combination of both. Just giving it one more check, and there we are. 4.499 on the mic. All right, job is just about done. Our V-jaws for the fireball vise have been working great for this job here. All right, impeller number 6 completed. I hope this helps them out, gets them back in order. All right, guys, our impeller job is complete. I'm ready to give them a call. I'm sure they're going to come right on over here and pick these guys up. But I'm happy with the outcome. We fell on all 6 of our impellers. We fell right within that 1/1000th tolerance that they were asking. This was the paper that they give me. They wanted 4.498 to 4.499 on the diameter of the seal rings there. So we took about 0.005 off of all 6 of them. And one of the things that I noticed is that most all of them, there was one, it was either 4 or 5 that was running pretty darn true. After we got it in the lathe and I touched off, it was pretty true. Now the other 5, it took that 0.005 to get them cleaned up and get them round and fall within that size that they asked for there. So they're definitely going to have to do some more balancing on these things, and I'm sure that they will, because they have a balancing machine over there that they balance these rotating assemblies before they install them. But real happy with the outcome. They look good. Our snake oil worked pretty good on that, so happy with that there. We got good finishes on it. We didn't have any issues with chatter or anything like that. So just a good overall job. So this one's completed. I'm going to give them a shout so they can come and pick it up. I actually have 2 more jobs over here on the table that I got to do for them. So we do have a couple more. It's not going to be a shaft. We got some pipe flanges that I need to machine, some custom sized pipe flanges. We'll probably incorporate both manual and CNC to do that. I probably want to use my touring mill to drill the holes in it, because I just absolutely love watching that machine drill holes. It does it so fast. And we have another part that's going to be some lathe work. I just got this one bushing that I need to machine. So we'll probably come over here to the manual and knock that out too. So that's some upcoming jobs that you'll see pretty soon. But that's it. Let's wrap this up. I hope you guys enjoyed the video, and I hope to see you back here for the next project. All right, we'll see you then.